Okay, so we made it to a lesson 11.8. This is the last lesson of geometry. Congratulations! Here we're going to find the surface areas and volumes of spheres. So a few pieces of terminology first. Okay, so a sphere, by definition, is a set of all points in space equal distance from a given point. So you have a center point here. All of these distances coming out in every which way are equal distance to the center, and that's what makes up a sphere. Okay, now the point in the center is called that center, okay? And then a radius of a sphere is a segment from the center to a point on the sphere, so in any direction. We'll keep it similar to how we've drawn it before with regular 2D circles. Okay, so that's the radius of a circle. Now there's this new term here, a chord of a sphere. Oh, sorry, that was a radius of a sphere. A chord of a sphere is a segment whose endpoints are on the sphere. So just two endpoints on the sphere and you connect them. Okay, that's about it. But where this comes into play is that the diameter of a sphere is a chord, because it has two endpoints on the sphere, but it's a specific chord and then it passes right through the center. Okay, so a diameter, everything, it's the same, but because we're talking about a sphere, that's why it requires a little bit more explanation. All right, and then so as with circles, the terms radius and diameter also represent distances, and those have values, and diameter is twice the radius, as we've known. Now, if a plane, as this plane does here, if it intersects the sphere, then it's either going to intersect it like right on the tip or on a side, in which case it's only going to intersect at a single point, or it's going to go ahead and intersect the sphere making a circle. Okay, so as we see here. All right, now when that happens, if the circle that it intersects is right in half, so if it goes right through the center point, then it's known as the great circle. What I think of are like with a globe, you know, the Earth. When you guys learned this, you learned about the equator and the prime meridian. Those ones are the largest. That's all that really is. And so that great circle is this cross-sectional area there. The circumference of the great circle is what the circumference of the sphere is considered to be. And whenever we have a hemisphere, the great circle of the sphere separating, it separates it into two hemispheres. Okay, so again, think of the equator. All right, now let's talk about surface area and then volume, and we'll see where that can lead us. So surface area formula, if you want to see where this one's derived, this one's not as easy to follow, which is why we're not going to get into it, but you're welcome to look that up if you are curious about it, okay? We, however, though, are just going to go ahead and use the formula as is. So surface area equals 4 times pi times the radius squared. That's it. And r is our radius. Okay, so let's try example A here. So surface area equals 4 pi r squared. So it's pi r squared, it's basically the area of a circle, times 4. All right, so then 4 pi, my radius is 8 squared, so that's 4 times pi times 64, and 64 times 4. Again, we'll always I'm always going to write these in both directions. I can write this as 256 pi, and we're talking about surface area, so it's inches squared. Or I can multiply that by pi and round it to 804.25 inches squared. Either one is acceptable. Just make sure you pay attention to the directions about what they're asking for. Okay? Whoops, sorry about that. All right, so continuing on, we're going to go ahead and look at letter B. And this one, they give us that the circumference is 12 pi. Okay, so with that in mind, I'm first going to keep in mind my circumference formula is 2 pi r. All right, so I'm going to substitute in 12 pi for circumference, 2 pi r, and I'm solving for the radius. So my pi's are going to cancel. I can divide by 2, and I find that the radius of this sphere is going to be 6 feet. Okay, so now the formula that I can put in for the surface area is 4 pi r squared. I can replace the radius now with 6, which is why I had to do that. So I get 4 pi times 36, or that turns out to be, 144 pi feet squared, which is approximately 452.39. 452.39 feet squared. Okay, all right, let's go ahead and try some on the next page. We're going to work through these. So here they want us to find the diameter of the sphere. They're giving us the surface area. So surface area is 4 pi r squared. I'm going to replace surface area with 20.25 pi. Now notice there's no diameter in my formula, but that's okay. I'm going to cancel out the pi's, divide by 4, and 20 1/4 divided by 4 is going to give me 5.0625. I'm going to take the square root of both sides to go ahead and find what my radius is. And that's going to give me a nice 2.25. So that's my radius, and since they want the entire diameter of this circle, I'm going to multiply that by 2. So my diameter is just going to give me 4.5 centimeters. Sometimes the hardest thing is just paying attention to the units that you're using. All right, number 1 then, we're just going to practice through these. So they're giving me the diameter. So surface area is 4 pi r squared. Since they're giving me the diameter, I'm going to replace, instead of 40, I'm going to only put 20 here. And we know that when we square it, it's not the same as multiplying by 2, so we want to be careful with that. 4 pi, this is going to be 400. So one answer is 1600 pi. My other answer is going to be 5,026.55. Both of these are feet squared. Sorry, that looks funny. Okay, all right, let's do number 2. Here they're giving me the circumference, so I'm going to do a little bit of back work. Circumference of a circle is 2 pi r, so circumference here is 6 pi. My pi's are going to cancel. It's always nice when that happens. Divide by 2, so the radius is 3. So now I can substitute that into 4 pi r squared. 4 pi 3 squared. 4 times pi times 9, which is 36 pi feet squared, which is approximately, I shouldn't put equals, but approximately 113.1 feet squared. Okay? And one more of this type. Let's try number 3. Find the radius of the sphere. Okay, so surface area is 4 pi r squared. I'm going to go ahead and replace surface area with 30 pi. My pi's are going to cancel. I can divide by 4 on both sides. 30 divided by 4 is going to give me 7.5. So 7.5 equals the radius squared. And so whenever I take the square root of that answer, I'm going to get not a nice neat number, but about 2.74 meters. Okay? That's approximately. And it's always nice, you can work backwards and sub it in and see if it works, and that's the right answer. All right, let's move on to volume now. So formula here is a little bit different, but very similar. It's 4/3 pi r, not squared, but cubed. Okay, 4/3 pi r cubed. All right, so let's try one. In this first one here, we have the volume of a soccer ball. So volume equals 4/3 pi r cubed. I'm going to replace the radius with 4.5 because that's what they're giving me. Now on my calculator, I'm going to do 4.5 to the third, and I'm going to multiply that by 4/3. And I get 121.5 pi. Now here we're doing volume, so I can label this inches cubed, or I can again always multiply by pi, and I get 381.70 inches cubed. So volume, again, we're not going to do too many of those because it's just a matter of substituting into the formula. But let's try these ones where we're finding missing pieces. It says the surface area is given. Use this to find the volume. Okay, so the surface area formula we just finished is 4 pi r squared. Let's figure out what the radius is, just because that's the unknown that we aren't given. 324 pi is my surface area, equals 4 pi r squared. My pi's are going to cancel. 324 divided by 4 gives me 81. So that means that my radius is 9. And we're talking in centimeters here. Now I'm going to use this when I do my volume formula, which we just saw is 4/3 pi r cubed. Okay, so 4/3 pi times 9 cubed. 9 cubed is 729. Multiplying that by 4/3, I'm going to get an answer of 972 pi centimeters cubed, or 3,053.63 centimeters cubed. And that's what we have. Okay? All right, 2 more problems. Find the volume of this composite solid. So I have half of a sphere, and I'm going to add that to a cylinder. I'm sorry, let's rewrite that. That is what I have, but when I relook at my picture, it's kind of hard to tell. This, though, is cut away. Okay, obviously it's not adding it, but so instead the way I'm going to do it is this way. I'm going to take my cylinder, find the volume of that, and subtract from it that cutaway hemisphere that is taken out of there. Okay, all right, so you would always have formula sheets here. You don't have to have these memorized, but the formula for volume of a cylinder is pi r squared h. So let's just do that on its own. So pi, the radius of my cylinder is 2, and the height of my cylinder is 2. Okay, so that's 2 squared is 4. 4 times 2 is 8. So this is 8 pi. All right, it's nice to kind of get that out of the way. Now I'm going to go ahead and subtract. Now this is a half of a sphere. So instead of it being 4/3 pi r cubed, it's a half 4/3 pi r cubed. I want half of it. And I can do a little simplifying here, so it's going to give me 2/3. So I'm going to subtract 2/3 pi, and my radius here is still 2. It's still the radius of that sphere, so 2 cubed. Okay, I'm going to kind of do that one. Well, I'll just keep working down. So 2/3 pi, 2 cubed is 8. Multiplying straight across, 2 times 8 is 16, so I get 16/3 pi. Okay, all right, so let's erase all of this. I'm just going to rewrite that as 16/3 pi right here. So now I'm doing 8 pi minus 16/3 pi, and all they really want in the end is the answer. If I do my fraction work, this comes out to be 8/3 pi, or I can rewrite that as 8.38 inches cubed. Good work, guys. Okay. All right, last one here. We have the volume of this composite solid. Here, the order doesn't matter because we are going to add them. So I can go ahead. Let's do the volume of the cone. We'll add that to, again, we have another hemisphere, so it's half of our circle. So volume of a cone is 1/3 pi r squared h. So let's just do that portion alone. 1/3 pi. The radius of my cone is 1, which is convenient. The height of my cone is 5. So 1 squared is 1. So this is really going to be 5/3 pi for the volume of my cone. Now, we're just like we did before, this is 4/3 pi r cubed. That cancels out. All right, so now I have 2/3 pi. My radius again is 1, which is pretty convenient. So this adds to my answer 2/3 pi. If I add those, I get 7/3 pi, and this is meters cubed, or that is the same as saying 7.33 meters cubed. Either answer is equivalent. Perfect. All right, great job, everyone. Wonderful work. I'm so proud of you, and I thank you for all the hard work. Bye, guys.